You've probably used a dozen services today that rely on Amazon S3 without even realizing it. It's this invisible backbone of the internet. So today we're going to deconstruct it. We're going to peel back the layers and see how it really works. Let's get into it.
All right, so here's the plan. First, we'll cover the basics, what S3 even is. Then we'll get into how it actually stores stuff. We'll look at the high-level architecture. And then, and this is the fun part, we'll do a really deep technical dive. And finally, we'll see some of its key features in action. Let's go.
Okay, Section 1. What is Amazon S3? It's really the bedrock of cloud storage. To understand it, you kind of have to go back to the beginning, way back to 2006. It was one of the very first things AWS ever offered, and it was built on this foundation of making some absolutely wild promises about your data. Let's see what those are.
Okay, look at this number. Seriously. 11 nines. 99.999999999%. What does that even mean? Well, it's called durability, and it's a promise that your data won't just disappear. To put it in perspective, if you stored, say, 10 million files in S3, you could expect to lose maybe one of them every 10,000 years. It's just an insane level of safety.
So how does it pull off that crazy durability promise? Well, it's built on these core ideas. It has to be scalable, meaning it can handle basically an unlimited amount of data. It has to be highly available, so you can actually get to your data when you need it. It's super versatile. People use it for everything from backups to giant data lakes, and of course, it's got to be secure. All these things together make it the foundation for, well, pretty much everything.
All right, next up, how does S3 actually store all this stuff? Because here's the secret. It's nothing like the file system on your laptop, not even close. And that difference is the entire reason it can scale to the size of the internet. Okay, this chart really breaks it down. Think about your computer's file storage. It's all folders inside of folders inside of folders, right? That's a hierarchy. S3 throws that whole idea out the window. It uses object storage. Everything just exists in one gigantic pool, like a cosmic key value store. There are no folders. This flat structure is the magic trick. It's what lets S3 scale forever without getting bogged down.
So what exactly is an object? It's pretty simple, actually. It has three parts. You've got the data itself, the picture, the video, whatever. Then you have metadata, which is just data about the data. Things like, what type of file is this, or when was it created? And finally, you have a globally unique ID. It's the object's address on the internet. The library book analogy is perfect here. The book is the data, the card in the catalog is the metadata, and the call number is the unique ID. S3 bundles all that together.
Okay, so we have all these objects floating around in this massive pool. How in the world does AWS manage all of that? Well, it's not some single monolithic piece of software. It's actually a team of 4 distinct services all working together perfectly. Let's meet the team.
Think of it like a well-run operation. You've got the API service. That's the front desk, taking all the requests. Then there's IAM, the security guard who checks your ID to make sure you're allowed in. The metadata service is the clever librarian who knows where everything is located. And finally, the data service is the huge warehouse out back that physically holds all the stuff. Every single thing you do in S3 involves some combination of these 4. Let's see how that plays out. Okay, first up, creating a bucket. A bucket is just a container, right? So your computer sends a request to the front desk, the API service. The API service turns to the security guard, IAM, and asks, is this person allowed to create a bucket? If IAM says yes, the API service just goes to the librarian, the metadata service, and says, hey, make a new record for a bucket with this name. And that's it. Notice the warehouse, the data service, isn't even involved. We haven't stored any actual data yet.
But what about uploading a file? This is where it gets interesting, and the order is super important. The request comes in to the API service. It checks with IAM again. Once it's cleared, the API service first sends the actual file over to the warehouse, the data service. The warehouse finds a spot for it and comes back with a receipt, basically an ID that says, I put your file right here. Only then does the API service go to the librarian, the metadata service, and say, okay, for this file name, here's the ID where you can find the actual data. That 2-step process is crucial.
So downloading a file is, as you'd probably guess, the complete reverse. The request comes in, security check with IAM, but this time the API service doesn't go to the warehouse, it goes to the librarian, the metadata service first. It asks, hey, I've got a request for catpicture.jpg. Where is it? The librarian looks it up, finds that unique ID, and gives it back. Now, the API service can go to the warehouse, the data service, with that ID and say, go get me the data at this specific location. And boom, the file gets sent back to you.
Okay, so that's the high-level flow. But now we're going to go deeper. Section 4. What is actually happening inside that warehouse, inside the data service? How does it physically write your file to a hard drive when it's getting hammered with millions of requests for tiny little files all at the same time? This was the multi-billion-dollar problem the S3 engineers had to solve. See, your typical hard drive has a minimum file size. Even if your file is just 1 byte, it might take up 4 kilobytes on the disk. Now, imagine you have billions of these tiny files. You'd be wasting an insane amount of physical disk space. Not only that, creating a new file is a slow operation for a disk. Doing it billions of times would just bring the whole system to its knees.
So what was their solution? It's something called a write-ahead log, or WAL, and it's so clever because it's so simple. Instead of creating a brand new file for every tiny object, S3 just doesn't. It opens one giant log file, and as new objects come in, it just tacks them onto the end of that file, one after another in a long, continuous stream. Why is this so great? Because just appending to an existing file is one of the absolute fastest things a hard drive can do.
Okay, but wait, you're probably thinking, that creates a new problem, right? And you'd be absolutely right. If your 1 kilobyte cat picture is buried somewhere in the middle of a massive 2 gigabyte log file, how do you find it? You can't possibly scan the whole file every time. That would take forever. So how do they solve that? The answer is another simple, brilliant idea, an index. Think of it like the table of contents in a book. Every single storage server in S3 is running its own tiny little database. So as soon as it appends your object to that big log file, it immediately jots down a note in its local index. It records the name of the log file, the exact byte where your object starts, that's called the offset, and how long it is. So when you ask for that file back, S3 doesn't scan the log. It just does a super fast lookup in that index, which tells it exactly where to go. So this core design, the write-ahead log plus the local index, is just rock solid. And it's the foundation that lets AWS build all sorts of other powerful features on top. Let's wrap up by looking at a few of those.
For example, S3 is constantly running checksums to make sure your data hasn't been corrupted. What you get back is exactly what you put in. It has versioning, so you can undo accidental deletes. There's a whole garbage collection process to clean up old data. But the one I really want to focus on, because it's a real game changer for big files, is something called multi-part uploads.
We've all been there, right? You're uploading a huge file. It gets to 99% and your Wi-Fi drops. Ugh, you have to start all over. Multi-part uploads solve this. Your computer talks to S3 first and says, hey, I'm about to send you a big file in pieces. Then it uploads it one chunk at a time. If part 7 fails, no big deal. You just re-upload part 7. You don't have to resend the first 6 parts that already worked. Once all the parts are there, you send one final message, and S3 stitches them all together on its side. It is absolutely essential for reliability with large files.
So there you have it. We went from that wild 11.9's promise all the way down to the nitty-gritty of how S3 writes data to a disk. And I think the big takeaway is that incredible scale doesn't always come from incredible complexity. Often it's about finding really simple, really elegant solutions, like the write-ahead log. And that brings us to our final question. We've seen that S3 is this bedrock, but what else is down there? What other invisible genius systems are quietly holding up the entire cloud?